Okay, let's have a quick read of this question. A certain forest contains only trees of a particular species. DPAT wishes to take a random sample of 5 trees from the forest. He numbered the trees 1, 2, 7, 8, 4. Then using a calculator, he generated a random digits, blah blah blah. Using these digits, DPAT formed 5 3 digits. So from there he's gone 1, 4, 7. Then from there he's gone 4, 7, 8. He's rejected 7. He's going to reject that. No, he hasn't. That's okay. We can go with that. But he's going to reject this one, 810, because that won't be in the list. Okay, so we're getting that. Using that, and then he gets the second, third, fourth, and so on in this kind of as he moves along the list. Explain why DPAT omitted 810. Well, there's only 784 trees. Well, yeah, there's only 784 trees. Only 784 trees. No tree numbered 8, 1, 10 exists. So therefore, omit. Okay, so just a simple answer like that. Explain why DPAT's sample is not random. Well, it's not random because you start with that, and those numbers you get, they then stay in that order, and you just move along one. So as soon as you selected those, then there's no other number to be selected wrong from here. So what we can say is it's how would I describe this? In a list, and numbers remain fixed. Okay, from the previous one. So those numbers, those 4, 7, will be selected in this 4, 7 here too, and the 7, 8 will be in here. Okay, so you can also say the last 2 numbers will be in the next selection. So the last 2 numbers will be in the next selection, etc. So that's why it's not. Okay. Right. So let's go on the more important question, the 7 marker. So here we go. The mean height of all trees of this species is 4.2. DPAT wishes to test whether the mean height of the trees in the forest is less than that. Okay, so I'm going to underline that, less than that. That's what he wants to test. He now uses a correct method of random selection for 50. Now he selected 50 trees, so that's going to be it's going to be a sample of this. Okay, and the mean is 4. Okay, from those 50 samples. It is given that the standard deviation of the forest is that. Okay, carry out test at 2% simulation level. Now there's quite a bit of information here. First of all, we've been told that the mean height in the forest of all the trees, okay, of all the population, so we know that mean is 4.2. And we can say that is our mean for the hypothesis, null hypothesis. And DPAT wishes to test whether the mean of the tree is less than. So in his statement, he thinks the mean is less than 4.2. So that's important that we know the population's mean, and he thinks it's less than that. We also know that his sample mean is, what he got was 4. Okay, 4 meters that he selected that. Right, so all these there's a mark there, possibly a mark here, but you need to put this next thing. So we know that because it's a sample, the sample mean will follow a normal distribution, and in this normal distribution it will follow, we will say that the mean is what we are predicting it to be, what the whole forest is. However, because you can also put here that the sample size he took is 50 trees, and he said that the that the forest is standard deviation.
About 2 minutes, I just want to ask you a quick question.
Yeah. So standard deviation of the forest is that, so we can say that standard deviation is 0.8 squared, so that's the variance over 50. So we know that the sample runs like that, okay? So that's how we will set it up. So in our test, we need to say that what is the probability that this mean that is selected, okay, is going to be less than, or we could actually, that is the mean sample. Let's just tell you what, to avoid confusion, let's just call that x follows this distribution, and we want to know that x is going to be less than 4. So this sample, this x which is going to follow here, is going to be less than 4 meters. That's what is kind of found at the moment. So if you do that and you run it through your calculator, just put that through your mode. It's normal distribution mode, and it's going to be mode 7. If you put that through your calculator, you get a probability of 0.0354. Now from here, also what you could have stated here, and it's pretty obvious, but you could state here, and I should have stated it, that it is a one-tail test, and significance level is going to be, significance level is 4, I think it was, no, 2%. And it's important at this point to write 2% is 0.02. And from here you can say that because this is greater than 0.02, it drops outside, okay? So this is the outside rejection region, this is above that. So in this case, do not reject H, the null hypothesis. Okay, so you can say that clearly. And then you've got, up to this point, you've got a mark, 1 mark, 2 mark, 3 mark, 4 marks, 5 marks up to here, 6 marks saying that, and your 7th mark, you have to state a statement, and you can say there is insufficient evidence to suggest mean is less than 4.2 meters, and that is it.